Looking at this next example here, we have the sequence where A0 is A, A1 is A times R, A2 is A times R squared, and so on. So our formula here for A of n is A times R to the n. Notice that the power of n matches the index of our term. So if we're looking at the limit as n goes to infinity of this sequence, we're looking at limit as n goes to infinity of A times R to the n. Because our R is between -1 and 1, it turns out that this limit is equal to 0. So to find a formula for our sequence of partial sums S of n, first thing we want to do is write out what our S of n is. Now this is simply the sum of the first n terms, so it's A plus AR squared up to A times R to the n minus 1. Now what we want to do here is now look at what happens when we multiply this by R. So our first term here now is AR, this is AR squared, so on. Basically what we have here is every term in our sequence now has one higher power of R. So now what we want to do is actually subtract these two terms from each other. So on the left side here, we get S of n minus R times S of n. Now on the right side, we look at these terms, and there's a bunch of things that cancel out. So this AR, we're subtracting an AR there. This AR squared, we subtract that there, and there's going to be AR cubed, so on. Turns out every term is going to cancel out except the last term. And so what we're left with here is this A, this is a minus A times R to the n. And so now we can use this equation here to solve for S of n. So what we get is S of n is 1, S of n 1 minus R is equal to A minus A times R to the n, or S of n is equal to A minus A times R to the n over 1 minus R. Or we may write this as A times 1 minus R to the n over 1 minus R. And now to compute the limit of the sequence of partial sums, we look at the limit as n goes to infinity of A times 1 minus R to the n over 1 minus R. Now the thing to observe here is that as n goes to infinity, this R to the n term here approaches 0. And so what we're actually left with here is A over 1 minus R. And so a